Hey everyone, in this video we'll be learning how to package Python projects. So let's first get started by initializing a UV project. Okay, so it will be UV init and name of my root project. In this case, I'll name it packaging study, and we'll wait for UV to initialize this project. Then we'll cd into it. And as you can see, UV has created a boilerplate set of files for us to get started with. And then we'll go and open cursor IDE using cursor space dot command. Let's create a couple more files. So I'll create calc.py and define arithmetic operations there. So it will be add and subtract. Might as well define multiply and divide also. Then we'll go ahead and import this in our main.py file. We'll start our terminal and UV run main.py. Now, the moment we do this, UV will run sync command under the hood to make sure that it has looked at our pyproject.toml configuration file and created a virtual environment if it doesn't exist, and installed any dependencies if they are added here. In this case, we don't have any dependencies, so UV will only create virtual environment and invoke our main.py file. So let's run this. As you can see, it's created virtual environment.venv and executed our code. Let's create one more file. We'll name it otherops.py and we'll define other func. It's returning nothing. And we will import an external package here. So we will be importing numpy as np. We will be printing numpy version. Let's also import other func from otherops into this main.py file and call it. Before invoking main.py, let's also add dependency in our pyproject.toml file. Otherwise it will give us a module not found error. So now we can run main.py and it will look at our virtual environment and recognize that we don't have this dependency installed. So it will install that dependency and then invoke main.py logic. As expected, it's given us numpy version as well as this line from other func. Now, so far we have three Python files. We have calc.py, main.py and otherops.py. You can also think of this Python files as modules. So a module in Python is basically a file that contains Python code. It might contain functions, classes, variables, other objects. In our case, we have functions in our three modules. Main.py can also be called as an entry point. So it's not just a Python module, but it's also an entry point in that it's the file that is invoking our program. So we are writing modular code in otherops and calc.py and we are importing that and then calling our program by invoking main.py. Now, usually in serious Python projects, you will not have a situation where we'll have collection of files like this in a very flat layout. We'll have different folders under our root project, and those folders will contain some more nested folders as well as Python files. So let's create a folder and we'll call it my folder, and we'll move calc.py as well as otherops into my folder. Now at this point, if we try to run main.py, it will throw an error, and the error is quite descriptive in that it's not able to find calc module. Why is it that it's not able to find this module calc? All we did was move calc and otherops under this folder, my folder. Logically, it seems that it should be able to find it because my folder is located right next to main.py. The reason why it's not able to find those modules has something to do with what we call sys.path or module search path in Python. So in order to see what that is, let's import sys module, and this is a built-in module which comes with our base Python installation. And then we can print sys.path. So let's invoke our main.py. This is basically the reason why we are getting no module named calc error. Anytime we run or call a Python program, there are certain set of locations or directories that Python searches in order to make sure that that program is successfully executed. And that list of directories is given by sys.path. Now the first entry in our sys.path or module search path will always be the directory that contains input script or script which we are currently invoking. In our case, that is main.py, and the first entry reflects the location of main.py. Then the entries after that, so this one, this one, this one, and this one. In fact, let me just print this in a more organized way, so it's easier to look at different locations. As we discussed, first entry is the location of our main.py script, which we are calling as an entry point to our program. Then this location, this location, this location, and this location. All of this are reference to our core or base Python installation. So if I go to this particular location in our local machine, This is our base or core Python installation, which is managed by UV. So if you were using pip, then this will be equivalent to the Python that you install from python.org. And this obviously will be distinct from the Python that we have in our virtual environment. Especially important in our core Python installation is this folder, lib, which basically contains standard library or packages that come in our base Python installation. We already know that pandas, numpy, scikit-learn, etc. These are external packages which we have to either pip install or UV add. But this lib folder in our base Python installation are the packages which come pre-built. So these paths are basically Python paths or paths to our core Python, and most importantly, pointer to our standard library. So just to drive home why this particular reference is important is if we were importing something from our standard library, for instance, let's import OS. Now this is something which comes in our standard library. In fact, we can find it within this folder itself. So if we try to find OS, it will be right here. We can find out the location from where we are importing this OS module by using this logic os._file_. So let's run this. And as you can see, the output of this code os.get current working directory gives us our current working directory. And this code snippet gives us the location from where we are importing OS module. And in this case, we are importing it from our core Python installation lib folder. That is what we saw here. This is where we are importing it from. So after the directory location of input script and locations for our base Python installation, we have a couple of references to our virtual environment. So if you look at this location, this is where Python will be able to find our main Python interpreter engine that it needs to execute Python code. And this location is where it will look for any external packages like numpy, pandas, scikit-learn, etc. that don't come pre-packaged in Python's standard library. So we can confirm those two things. We can use sys.executable in order to find out which Python interpreter our code is using. We can also import numpy, but instead of numpy version, what we need is the location where numpy is coming from. So this is the same logic which we use to get the location from where we are importing OS module. So let's run this. As you can see, our Python interpreter is coming from .venv, our virtual environment. And our numpy file path is from .venv lib site packages, which is again where all the external packages will be found. And if Python cannot find that external package here, it means that it will give us module not found error, and we'll have to either UV add that dependency or add it here in the dependencies list and then just run UV sync or UV run. So having seen our sys.path, the reason why we are getting module not found error when we are trying to import calc, and we'll be getting the same error if we try to import other ops. If I just comment this out and I comment out the functions I'm importing from calc and again try to run this, it will give us the same error that it's not able to find this module other ops. The reason it's happening is because in our list of module search paths, it doesn't have the location of my folder. Okay, it has the location of packaging study, which is our root directory, but because it doesn't have the location of my folder, the only location it will be trying to find calc.py and otherops.py is under packaging study. So it imagines that these two modules have to be located next to main.py, which is what the case previously before we moved them to this my folder. And because it's not able to find it in that location, it's giving us the error. So one of the hacky ways of resolving this is just append the my folder path or my folder location to sys.path. So if we append, now here we can either give my folder, like this will also work, or we can give the absolute path of my folder. Okay, both of that will work. When we append this path to our sys.path, it should be sys.path actually. So appending this location to our sys.path list means that Python now has access to my folder location and it will be able to find calc and other ops. So let's run this code. And this time it should not give us module not found error. Okay, and as we can see, it successfully imported the modules and executed the code from those modules. But again, this is a hacky and not a good way of doing it. You should almost never manually change your sys.path. So in our case, the way to get around this issue is just modify our import statement. Instead of from calc, we should have my folder.calc, because it will be able to find my folder as it's located under packaging study, and packaging study is our input script location. So it's there in sys.path. So if we use my folder dot the respective module names, then it should again be able to find those modules and not give us the error. Now there is too much noise in our main.py file. So let's create another file and we'll just call it thirdops.py and we'll move all of this code to our third func, hello from third func, and then we will print this. We don't need numpy import because we're already importing it in other ops module. So we can get rid of that. We can also import our OS in thirdops.py. And as it's suggesting, we can import third func from third ops and we can also call it here. Okay, so let's rerun our main.py file. And as you can see, it's correctly getting executed this time. Now we can also consolidate our import statements. So instead of importing functions like this, we can import all of them at once. And we can do the same for the other two modules, even though there is just one function in each of them. Okay, so what this will do is we are importing everything that's there in calc module, everything that's there in other ops, everything that's there in third ops. And this also will be successfully executed. Oh, right, I forgot. So whenever we import using asterisks, our imports need to be at the beginning of the module. Okay, they cannot be in the middle of our code. Running this again, as you can see, it's correctly running. Now, what if we want to simplify this even further? So what if we want to do something like from my folder, import everything? Now this will be different compared to what we did previously. So previously we had this where we are importing all the functions, classes, variables, etc. from our modules. But what we will be doing now, if we run this, is we are importing all the modules from our my folder. Obviously in that case, because we now have modules imported, we have to call these functions by pointing to our modules. So we'll be calling calc.add, calc.subtract, etc. And then similarly we'll be calling otherops.otherfunc and thirdops.thirdfunc. But this will not run. So if we try to run it, it will give us the error that the name calc is not defined. So why is it that this is not working? In order to make this import statement work, we'll have to discuss what a Python package is and the role that init.py file plays in it. First, let's create a file init.py under my folder. So we'll create it using _init _.py. Okay. And then we'll go back to our main.py and we'll revert to previous import statements. Now init.py, it's a file that initializes or declares Python package. Think of it like this. So we have a definition of class. If you don't already know, in a Python class, we have a method called _init . And anytime you are instantiating a class, it will always initialize that class by calling init method. So I'm not doing anything other than just instantiating the class. It will print this statement if I run it. So let's run our main.py. And as you can see, we have my class initialized. Init.py file under a folder plays a similar role in that anytime we call that folder. So in this case, my folder, which consists of this Python files, calc.py, otherops.py, thirdops.py. Anytime we call or invoke that folder using an import statement like this, by default, our init.py file will be called first. What does that mean? Let's print something out in our init.py. So we'll print out this statement and our expectation is that if we run our code, it will have that print statement at the very start and it's only printed once. How you should remember init.py is anytime we have a folder that consists of init.py file in an import statement, it will first invoke init.py file and any code that exists within that file, but it will only do it once. So even though we have 3 import statements where we are calling my folder modules, there is only once that that print statement is run. So just again to summarize, anytime we have a folder consisting of init.py file called, usually in an import statement, it will run init.py file once. Another thing to remember about init.py file is it explicitly declares a directory as a Python package. So any directory that consists of Python files or modules is basically a package. The reason why we can run this import statement where we are kind of referencing myfolder.calc or myfolder.otherops. So we are referencing modules within a directory. The only reason we are able to do this is because my folder is considered a package. What init.py does is it explicitly declares it as a package. It used to be the case in older versions of Python 3.3 and earlier, where we would not be able to run this import statement where we are calling a module by invoking myfolder dot that module name without having an init.py file. So without init.py file in earlier versions of Python, this will only be a directory consisting of Python files or modules. And in order for it to be a package, we had to create init.py file. But in recent versions of Python, that's not the case. The moment we have a directory which consists of Python modules, it's considered a package, and we can run import statements like this. Where init.py comes into the picture is because it will always be run at the start of the import, we can have different setup or config operations being called in this file. Another use case for having init.py file is it will help us streamline our imports. So when we were trying to import all the modules here, this is not the code that was working. So we already saw that this is failing, and this is where we can make this work by adding this to our init.py. So what will end up happening is we are importing all the modules under our myfolder package. So at the point of this import statement, it will look at the init.py file and it will run this piece of code and end up importing all the modules under it. Okay, so now if we run this main.py file, oh, actually I made a spelling mistake here. So it should be add. So now our code works correctly. Now it's not generally considered good practice to import modules like this using asterisks. So usually what we do in our init.py file is we end up importing individual functions like this using this dot calc notation. So dot is basically just to make sure that the imports are relative to where we currently are in this package. What dot calc is doing is telling init.py to look for calc module in the same package, and same for the other two modules. So because we have this 3 lines added in init.py, we can now directly import those functions, which is not what we were doing previously. So if you remember, previously we were individually importing those functions like this, but because we have made that change in the init.py file, we can now streamline this and directly import our objects or our functions. And we can get rid of our module reference in our function calls and run our main.py file. It will work. And this is generally how I like to use init.py. I don't like to have any code inside init.py, but I do like to consolidate or streamline my imports using this kind of syntax. Now this import statements can get tedious and convoluted very fast the moment our project hierarchy becomes even slightly more complex. So for instance, if instead of keeping this main.py file under our root project, let's move it to a directory. So we'll create a scripts directory under our root project and we'll move our main.py file there. Now if we try to run our main.py script, it's giving us no module found error. And that makes sense if we especially look at our sys.path. And let's move our import statement below it so we can see the output of sys.path. So let's run this. As you can see, now our main.py directory has moved to scripts folder. It is trying to find myfolder package right next to main.py file under scripts folder, but that is not the case. It's located one folder above scripts. So one way we can try to resolve this is by using relative import. All we need to do is move one level above where our script is located in order to make this work. So let's try that and see whether it works or not. So this is one of the most annoying errors that you will see, and you will see it often, especially if you don't understand why it's happening. What we are trying to do, we are telling our main.py file that in order to find this package, what you need to do is climb one level above your current location. That is where you'll be able to find my folder package. But the problem is that our main.py file is not aware of its package hierarchy. Okay, and that is what this error is trying to tell us, that we are trying to attempt a relative import with no known parent package. So let's understand that in depth. So right after our sys.path, we will print package. This tells us the package hierarchy of where our main.py file is located. Logically, it should be scripts.main. That is the package hierarchy of main.py. Now if we try to run this, see, it's showing none. And that essentially is the problem, that for us to do successful relative import, main.py file needs to be aware of the package hierarchy and climb one level up to find my folder package. The way we inform main.py of its package hierarchy is, instead of calling it as a script, we call main.py as a module by using Python -m scripts.main. So we are calling main.py as main module along with its package hierarchy. Now if we run this, it's showing main module is located under scripts package. So in this case, it will be able to climb up. Let's double click on this package hierarchy part by further nesting our main.py file. So we'll create another folder under scripts. We'll name it super nested and we'll move our main.py file under super nested. So now we have scripts.supernested.main module. Let's call the main module by giving its package hierarchy in scripts.supernested.main. And as we can see, now that hierarchy is getting reflected. Let's make the change in relative import to account for that super nested folder. So now we don't need to climb one level up, we need to climb 2 levels up. So we'll use 3 dots to indicate that. And then let us again rerun our module call. So it's still not working. So what it is telling us is that we are attempting a relative import, which is this, but we are doing it from a top level package. Now, why is it giving us that error? The reason it's giving us that error is, look at the sys.path first entry. Unlike a script call, so when we, let me again just call main.py script. If you look at the output of our script call, the first entry in sys.path is the location of our script. So it's pointed to super nested folder. But the problem is when we make a module call, it will not be pointed to the main.py location. Rather, it will be pointed to the location of our package hierarchy, because that is where we are calling our main module from. We are calling our main module from our root project and we are calling it using package hierarchy syntax. So it will not be pointed to super nested folder. Rather, it will be pointed to our root project folder where this entire package hierarchy is located. And that is why we are getting this error. In effect, what we are doing is we are located at our root project already. And from there, we are still trying to climb 2 levels up, which confuses Python. So now we can resolve this by first either getting rid of this relative import because we won't need it. If we make a module call, then our sys.path is already pointed at our root project from where it will be able to locate my folder package. Make a module call to main.py. Okay, so it imported this set of functions correctly, but it failed because it's not able to recognize numpy. And the reason is because now we are no longer using UV. So we'll need to activate our virtual environment. It won't be able to automatically find it because we are not using UV. And now our output will be successful. So that's one way of resolving this, where we make the module call instead of script call, and we account for the fact that now our sys.path location is that of root project. Another way to resolve this is we can get rid of the module call and we can use script call and append this particular path to sys.path. So if we revert to calling script instead of making a module call, we are running into the problem of module not found because our script location is further nested compared to where my folder is located. Okay, it's 2 folder down. So we can resolve this issue by simply adding this particular location to our sys.path. Okay, let us append this path to sys.path. So now if we run this, it will execute correctly. And the reason it will do that is because our sys.path at the end also has a reference to our root project, which is where my folder package is located, and UV will be able to find it from there. And this would have also run if we hadn't kept our virtual environment activated. So we can deactivate virtual environment, but because in this case we are using UV, it will be able to find the virtual environment and import numpy properly. So this is the second way of resolving that issue. There is another way of resolving this issue is simply by moving this my folder package into super nested folder. Okay. When we do that, because that folder is located under the same location where main.py script is located, it will have no issue finding it. So we can confirm that part by calling main.py script, and this time our code runs properly because our input script location is the same as our my folder location. But obviously that doesn't make any sense because we'll often have scenarios where we want to keep our logic segregated into different packages. So in this case, our my folder package has our core functionality or core logic, and our scripts package has our main.py script, and we don't want to mix those two. And if we run this now, it will obviously fail. So these are 3 different ways we can resolve this issue where our project hierarchy is slightly more complex, but that is breaking our imports. Now, none of these 3 ways of resolving these issues are considered good practice. All of them are different degrees of convoluted and bad practice. The most optimal way of solving this, especially considering the fact that a project might get more complicated, is using something called UV build and defining top level package hierarchy. So UV is always aware of our detailed project hierarchy, and that we'll discuss in the next video.